Welcome to Learn to Code Chapter While Loops. We're on the second activity, creating smarter while loops. In this activity, we are going to use a while loop, again, just like the last time, to toggle all the switches that need to be toggled in here. So in this case, we have seven switches have already been toggled open. We have 4 more that remain to be opened up. Let's run this again. See if it changes. Yeah, this time only 4 have been opened, and so we're going to need to toggle 7 of them. So the configuration of this puzzle changes each time. It looks like the layout of the puzzle stays the same as far as the number of tiles, but whether or not switches are on or off differs every time. So we're going to need to be careful. And we write this code so that it works in all different cases like that. Okay. Now, just to remind us what a while loop is here, a while loop is, if you think about maybe if you've played soccer before, when you're starting off and playing a soccer game, you don't say to yourself, everybody's going to dribble 25 times, pass 8 times, and shoot twice, and then the game is over. That's not how it works, right? If you've got 15-minute periods in your soccer game, what you're going to say, the rule for the soccer game is, as long as the time we've played is less than 15, we keep dribbling, passing, and shooting. Okay? So those things, dribbling, passing, and shooting, are our commands or our activities that happen inside our while loop, and the condition is while the time we've played is less than 15 minutes, we keep dribbling, passing, and shooting. Okay, so these while loops, they're very powerful, and they're very similar to how we work and play in real life. More so, I think, than the for loops. Although both of them have their place, and we'll learn more about how you choose which to do when as we progress through this course. Okay, but for now, we're working only with while loops. And let's take a look at this puzzle. It says we're going to use a while loop and an if statement to open all the switches. So some of the switches are closed and they need to be opened. Now, the while loop here, we want to keep doing something as long as something is true. All right, and the thing we want to keep doing is moving forward and toggling switches that are closed to be opened. Now, you might say, well, how do we know when we're done with that? Well, since it looks like the switches are all in a row and there's really no gaps in the switches, we could say as long as we're on an open or a closed switch, we want to keep moving forward and opening the closed switches. That might work, right? Let's try that. So let's start typing while, okay, while, and if I tap the while down here, I'm going to get a while loop construct filled out for me, or a lot of it. So the condition we said here, really we want to check if we're on a switch, we want to keep going, but there is no on a switch condition here. There's only is on open switch and is on closed switch. But we can use both of those. Remember, we have that or logical operator. So we might be able to say something like, while we're is on an open switch or we are on a closed switch, is on a closed switch, we want to keep doing something. And that thing we want to keep doing is to move forward and then check the next switch to see if it's open. If it's closed. If we're on a closed switch, then we want to open it, toggle it. Okay. So what we're going to do here every time is we're going to move forward, check if we're on a closed switch. If we are, we're going to open it. If we're not, we're going to come back up here and check our while condition again and say, are we on an open switch or a closed switch? If we are, we want to move forward and check. If it's closed, we toggle it. And if not, we come down here again, we come back up to the top and we say, are we on an open switch or a closed switch? Which is just saying, are we on a switch? If we are, then we move forward again, check the next one. If it's closed, we toggle it. Okay? Let's try this and see how it works. So let's run our code. I'm actually going to step through our code here so we can watch the while condition being checked every time. Okay, it's going to get checked the first time, and as long as we're on an open switch or on a closed switch, we will do this. So let's step and run our code. I think there's going to be a problem here. Yeah, Byte is not moving forward at all, is he? And that's because we didn't check our very first condition here. Our very first condition says we are not on a switch right now. So our while loop will never happen. Okay? We're not going to happen because we aren't on here, so it's going to be false the first time. We're not on a switch. So let's go ahead and move forward so that we get on this row of switches. So let's move forward one at the beginning. Now that we're on this row of switches, it should be true for a long time that we're on an open switch or a closed switch. Let's try it again now. Okay, so we move forward. We're going to check if we're on an open or a closed switch. Forward, we check we're on a closed switch, so we move forward and we toggle it and so on. So, yeah, we've got some problems in here. It's definitely not working how we thought. So one of the problems is we have two move forwards in a row now. After we move forward, maybe, again, we'll be already on the switch. We need to check this one right here to see if it's open or closed. So this is another one of those cases, just like last time, where we want to maybe put this after we check and see the after we check and see if we're on a closed switch, we toggle it, then we'll move forward so that we're set up for the next one. Let's try this again. Okay, we move forward, we check if we're on an open or a closed switch. We're on an open switch, so we don't need to do anything but move forward. Here, we're on a closed switch, so we toggle it, looking good. Here again, we're on a closed switch, so we check, are we on a closed switch? We toggle it. Here we move forward and we check, are we on an open switch or are we on a closed switch? And Byte stopped. Okay, Byte stopped. He stopped because we're not on an open or a closed switch right now. Okay, yeah, so these portals, really, they do chain us from one island to another here, but we do have a case where we're not, every time we transport over to a portal, we're no longer on an open or a closed switch. So we need to think of a new way to check and see if we're finished, because these portals are interrupting our logic that we have here. Can you think of another way to check and see if we're finished? Look at the very end row. And what's different about the end row than the other rows? This one's a little bit tricky. Okay, hopefully you figured out what's a little bit different about this end row is that we will move on to a tile here at the very end where we are blocked to the front. We're blocked here. We're blocked when we're on this tile, we'll be blocked. And we're not blocked, actually, when we move on to one of these portals. It may seem like we're blocked, but we actually, as soon as we move on to that portal, we transport over to this other place where we're not blocked. Okay? So we might want to change our while condition. Instead of looking at our switches to see whether we want to keep doing these actions, let's check and see. As long as we are not blocked, we want to keep doing this. So as long as we are not is blocked to the front, we want to check if we're on a closed switch and so on. So I don't need to have this move forward anymore because we will not be on a closed switch on our first tile. We won't be on a closed switch, and we'll just go ahead and move forward in that case. So I don't need to have this anymore. Okay, and let's try this out now. And again, let's run it by stepping through our code. First time we check, are we blocked? We're not blocked, so we do this code here, which just says move forward. Okay, now we're still not blocked. We check, are we on a closed switch? If we are, we toggle it and move forward. we're still not blocked. We're on a closed switch, we toggle it and move forward. We're still not blocked, we're not on a closed switch, so we just move forward. And this brings us over here, we're still not blocked. We are on a closed switch, so we toggle it, we move forward. We're not blocked, we're on an open switch, so we just move forward. This is looking good. Going, we're not blocked, we are on a closed switch, we toggle it, we move forward. This brings us to the final row, and we're not blocked, so we check, are we on a closed switch? No, we're not, so we just move forward. Again, we're not blocked, we're on an open switch, move forward. Here we're not blocked, we're on a closed switch, so we toggle it. And finally, we're not blocked, but we're on an open switch, we move forward. Here we are blocked, so the while loop stops. The while loop stops. We come down to the code that's after the while loop, and there is no code after the while loop, so we're finished with our program and we're done. Okay? Alright, so hopefully you're seeing this reads very nicely here. This is one of the other reasons I really like while loops, is because it really reads well in natural language, which we just say something like, as long as we're not blocked, we check if we're on a closed switch, and if we are, we toggle it, then we move forward. Okay? Alright. Good job, everybody. We'll see you next time.